So today, inshallah, we are going to do kinematics. Okay. Now you may be wondering, does that mean that we're done with forces? Well, not entirely, but the nature of M1 is such that praying for, yeah, please remember all of us in your prayers. So the nature of kinematics is such that you basically, oh, sorry, the nature of M1, yeah, the nature of M1 is such that we can't start one topic and do it all the way. So, like for example, since we started forces, we can't cover all of forces yet because in between we'll encounter some concept which requires the use of kinematics. Just like that, we can't do kinematics all at once because in between we'll encounter some concepts which require the use of forces. Okay, so kinematics and forces, we'll just cover them in a circular pattern. Then once we're through with that, then we can pretty much do any topic. Okay. Oh, all right, so I'll share my screen with you guys and let's get to work straight away. Now, you guys remember doing kinematics in O levels? Yes? Okay. So, we have a part of kinematics which is very similar to O levels. Okay? Yeah, today, like I said, we're starting a new chapter, but that doesn't mean we're done with all of forces. I just explained. We will encounter some questions in forces where we need kinematics, so we're going to do kinematics now. Okay? All right, so I'll share my screen. Have I done that? No, I haven't done that yet. Just a minute. Yeah, here we go. Now, before I start, let's look at what to expect in this topic. Okay, as always, it's very important to look at the kind of questions that we can expect. So you can break this down. You can break this topic into three parts. Okay, mainly you can break it down into three parts. One is where you have displacement slash velocity, or distance slash speed. My voice, what about that? Can you not hear me? No, no, I didn't ask what it is just yet. uh, it's बहुत खराब है. Abdullah, I think the problem is at your end. I don't know what you mean to say by that. Is that how it is by default? Is that what you mean to say, or you're saying you can't hear me clearly right now? Displacement slash velocity time graphs. Okay, I didn't ask the definition just yet. We'll get to that. Displacement slash velocity time graphs. Now this part is very similar to O level. Walaikum Assalam. I'm good. Similar to O level slash IGCSE Math. Only this part. Okay, and some more as well. Okay, it's not like it's a total copy paste. It's very similar to that, and then some basically. Then you have equations of motion. Equations of motion. So those of you who have done physics, this is something that you might have heard of already. If you haven't, we're going to do it from scratch anyway. In fact, I think we did a survey that all of you guys here are physics students, right? Even if you're not, don't think that at any point I'll just naturally assume that you know something already. We're going to do it in detail anyway. So equations of motion, one is when you have constant acceleration. Okay, and the other is also when you have constant acceleration, but that is acceleration due to gravity. Okay, so this is, you can say, category 2 of questions. Okay, remember how we broke down coplanar forces? So just like that, we're breaking down kinematics as well. And then you have calculus that's applied to kinematics. Now, any AdMath students over here? Yeah, so this is the part that is very similar to O level slash IGCSE admaths. So you have a slight edge over here. Further math, okay. Further, that means you must have taken admath as well, right? If you're doing further math, I'm assuming you must have taken admath as well. So yeah, very similar to that. Okay, very similar to kinematics that you had in O level or IGCSE Math. All right, now let's quickly go over distance displacement, the difference between velocity and speed. Maybe some of you know the answer to that already, but those of you who don't, it'll be a quick. Those of you who do, it'll be a quick refresher for you. Those of you who don't, you guys can understand what the differences are. So displacement and distance. Okay, now who can tell me the difference between displacement and distance in simple terms? Okay, I don't want a very bookish answer. I want a simple answer. Yeah.
Displacement is the shortest distance between two destinations, and distance is the normal path that we take to a specific point.
Okay. Okay. So if you write down the definition, displacement is basically the shortest distance between shortest distance from the starting point, actually. Shortest distance from the starting point, and the starting point usually is referred to as O. Okay. Another thing to keep in mind is that this is a vector quantity. Okay. And whenever the question says displacement, the question will say that it's distance from O, where O is the starting point. So sometimes the question will say displacement, sometimes the question will say distance from O, which means O is the starting point. So that is the distance from the starting point, which means it's the displacement. Okay. And yes, since it's a vector quantity, that means it can be positive or negative as well. Now, what does that mean? What does the positive mean and what does negative mean? We'll look into that in a minute. Another thing to keep in mind is distance. Distance is simply the total number of units that you've traveled. That's it. And this is basically a scalar quantity. Okay? That means it has only magnitude, it has no direction. So, in order to understand the difference, we're going to look at a very simple example, and this will help you understand the difference. Sir, is it important to mention? Oh, yeah, it is important. Okay. So let's say that you have an object over here, okay, which starts from this point here, oh, and when it's starting, time is 0, okay, and let's say it travels 20 meters in 1 second, okay, let's say it travels 20 meters in 1 second, okay, and at this point, let's say it turns, all right, O is the starting point. O is what we refer to as the starting point. And then at T2, whatever it may be, 3 seconds, 4 seconds, that's irrelevant. At T2, it has turned and traveled 16 meters in the opposite direction. Okay. And at T3, it is at a point which is slightly beyond the starting point in the opposite direction. Okay, we'll call that T3. And it's actually, to be precise, this is the starting point, and at T3, it's actually 6 meters in this direction. So, just a minute. Yeah. So at T3, this is where it is. It has traveled 6 meters in the opposite direction. Okay. Now, here's what I'm going to do. I'm going to make a table, and I want you guys to tell me the distance and the displacement at that instant. Okay. We're going to learn how to find. I don't want you guys to tell me. I will explain, and that will help you guys understand the difference between the two. Okay. So here's a simple table. In one column, I'm going to write down the time. In one column, I'm going to write down the distance, and in the other, I'm going to write down the displacement. Okay. So here is the time. In this column, we'll write down the distance. And in this column, we're going to write down the displacement. Okay. So at t equals to t1, what do you say? In fact, let's start with t0. At t0, the object hasn't moved yet. Okay, if the object hasn't moved, what's the distance traveled? It's 0. What's the displacement? That's also 0. Okay. At t is equals to t1, Okay, so this is where the object is. What will be the distance traveled? That will be 20. What will be the displacement? That will also be 20. Okay. Now, at t equals to t2, when the object has turned and it has traveled 16 meters in the opposite direction. Okay, so this is where the object turns and it has traveled 16 meters in the opposite direction. Okay, and remember, this object is traveling in a straight line. So it's going 20 meters in this direction, stopping, turning, and traveling 16 meters in the opposite direction. Okay, so it's not like this is not the path of the object, it's literally traveling in a straight line. Okay. That's what kinematics is, by the way. Kinematics is the study of an object moving in a straight line. I should have written that down. Kinematics, I'll write it down over here, is the study of an object moving in a straight line. Okay. All right. So what will be the distance? 36 because of 20 plus 16. What will be the displacement? The displacement will be positive 4 because it's on the right side. Okay. And you can see, you can understand that since displacement was positive 20 and here the object was 20 meters towards the right, here also since the object is 4 meters. Acha, I hope no one's wondering where the 4 meter came from. In case you are, there's a very simple explanation behind that. What will be this distance? This distance will be 20 minus 16, which means 4 meters, and at t2 the object is 4 meters away from the starting point. That's why the displacement is going to be positive 4. You don't have to write down the positive sign, but just so you understand the concept, it's positive 4 because it's on the right side. Now, what about t3? At t is equals to t3, what is the distance and what is the displacement? At t equals to t3, it's 46 and negative 6. Okay. 46 and negative 6. Okay, why 46? Because the object has gone 6 meters beyond the starting point. So what will be the total distance traveled? 20 meters in one direction, 20 meters in the opposite direction, and then 6. So 20 plus 20 plus 6. So 20 plus 20 plus 6, so that's equal to what? That's equal to 46. And what about the displacement? It's 6 meters away from the starting point. But if I just say 6, then how will we be able to distinguish whether it's on the right side or left side? We got to be able to distinguish between the two, right? That's why we say minus 6. So this minus indicates that it's on the opposite side or the other side of the starting point. Okay. Now, a very important note over here. A very important note. The note is, for as long as the object doesn't turn, what do we say? How are the distance and displacement of that object related? Okay, we're not talking about velocity just yet. Okay, we're not talking about velocity just yet. For as long as the object doesn't turn, what is the relationship between the distance and the displacement? For as long as the object doesn't turn. They're both the same. They're both the same. No, displacement is not 0. Dekho, when is displacement 0? We'll write that down. When is displacement 0? We'll write that down. Okay. Displacement is 0 when the object is back to the starting point. Okay. So a couple of key points that I'm going to write down over here, and I want you guys to pay attention. For as long as the object does not turn, meaning it started moving from a fixed point, which is O, let's say, and it's continuing to move in that direction. Okay, it's constantly moving in that direction, so that means it hasn't turned. So for as long as it does not turn, the distance is equal to the displacement. Okay, are we clear about this? For as long as, like for example, if this object continued to move in this direction, the displacement would have been equal to the displacement and distance both would have been the same. Okay. Point number 2. When the object is back to the starting point, what do we say? When an object is back to the starting point, what is displacement equal to? It's 0. Okay, the displacement is 0. Okay, key point number 3, when the object goes beyond the starting point in the opposite direction, goes beyond the starting point in the opposite direction, what happens is that displacement becomes negative. Okay, so 3 very important statements, which obviously we're not going to refer to again and again, but so take a good look at them. Take a good look at all 3 statements and let me know if you have any questions. Any statement that does not make any sense. Third point? Okay. Yeah.
I didn't get how is displacement plus 4 at T2?
Okay, this is where the object is, T2, at T2. How far is it from the starting point? This is your starting point. How far is it from the starting point?
4, sir.
And what's displacement? Displacement is a measure of the shortest distance of an object from the starting point. And because it's on the right hand side, that's the sign we consider as positive. That's why it's positive. Yes, the negative sign is to represent the direction. Okay. So for as long as the object is on the right hand side of the starting point, that means it's positive. And at T2, since it's on the right hand side, it's positive. Yes, it changed direction, but it's still on the positive side of the starting point. It's still on the right hand side of the starting point. Because it's changed direction, I think you're confusing this with velocity. Because it's changed direction, the velocity will be negative. That's not what we're dealing with right now. We're dealing with displacement only. Yes, it's changed direction, which is why you can see that the displacement has actually started doing what? It has started decreasing. So decreasing means what? If the displacement is decreasing, that means it's only because it's turned. Okay, but it will only become negative when the object goes beyond the starting point on the opposite side. So frame of reference is starting. Yeah, of course. See, that's what displacement is. Displacement is the measure of an object, the distance the object has traveled from the starting point. Okay, whereas distance, when we just say distance, is when you keep on adding the total distance the object has traveled. Okay, now I'll explain the third point. I hope it's clear now. When the object goes beyond the starting point in the opposite direction, displacement becomes negative. So you can see here, the object started from here and now it has gone beyond the starting point. Okay, it's on the opposite side of the starting point. What does that mean? That means it's 6 meters away from the starting point. But since displacement is a vector quantity, if I just say 6, then who's going to tell us whether it's 6 on the right side or 6 on the left hand side? We need something that can help us distinguish between the direction as well. So which is why it's minus 6. Why minus? Because it's gone on the opposite side. Okay, Momina, clear now? So that means the distance always increases. In fact, if you remember, back in O-levels, if we ever did a word problem dealing with distance, what happened every time we got a negative value? Let's say you did a quadratic equation and that quadratic equation was to solve the value of x which represented distance. What would you do with the negative value? We used to ignore. Why? Because distance, speed, and time, they can never be negative. Yes, you can say that 6 on the left hand side. You can say that, but just use the sign. That's good enough. Okay. All right. Now let's talk about speed and velocity. What's the difference? The difference between speed and velocity. Can you, I can swipe up for a second. Don't worry about it. Oh, no. We will not be done with all the concepts. We will just be done with this part of the concept, displacement, velocity, time graphs. Okay, so there you go, Amail. Let me know when you're done having a look so I can move on. Done? Okay. So speed and velocity. Let's talk about speed. So they're both very similar. Okay, they're both the rate of change of distance. One is the rate of change of displacement. Speed is a scalar quantity. It's always going to be positive. Okay. So speed does not take into account the direction in which the object is traveling. Velocity, on the other hand, is a vector quantity. Okay, so let's understand this with the help of an example. So let's say the standard rule is that normally when an object is traveling upwards, we consider it to be the positive direction. Okay. Now let's say we have an object which is, let's say it's a ball which is traveling upwards. Okay, somebody throws it upwards, and it's moving at a speed of 10 meters per second. So if it's moving up at a speed of 10 meters per second, and since the upwards direction in this case is considered positive, what can we say about the velocity? The velocity will also be positive 10 meters per second. Okay. Now, if the same object was traveling in the opposite direction, then what do we say about the speed and the velocity? Considering that the upwards direction is considered positive. What do we say the speed is, and what do we say the velocity is? Velocity negative, speed positive. That's correct. So if the object is now traveling in the opposite direction, the speed will still be positive, 10 meters per second. Okay, if it's traveling at a speed of 10 meters per second. The velocity, on the other hand, is minus 10 meters per second. So if you think about it, how does it really help? I mean, one might think that, well, what's the point? I mean, just the minus sign. Why is it necessary? How does it really help? It helps you, just like displacement with the sign helps you determine the direction the object is in compared to the starting point. Just like that, velocity helps you determine the direction in which the object is moving. Yes. And we use this in equations of motion. So again, a very important note, and the note is if velocity is negative, that means object is moving in the opposite direction. Okay, opposite direction, opposite to the one that you considered as positive. Okay. Now, any questions so far? If yes, please feel free to ask.
Sir, if we throw a ball in air, and for example, it has a velocity of 5 meters per second, but eventually it will come down. So when it is coming down, let's say with the same velocity, will that be minus?
Yeah, that will be minus 5, yes. Because velocity helps you distinguish between the direction as well. Okay, as far as speed is concerned, speed will be 5. But the velocity will help you determine the direction as well with the sign. Okay, and when we're doing equations of motion, not something you have to worry about right now, but when we're doing equations of motion, so equations of motion, those of you who are hearing this for the first time, so we'll have multiple formulas which involve the use of acceleration, velocity, time, displacement, and all of that. So in that case, when we're plugging in the value of v, we have to take the direction into account as well. So let's say we're solving a question where the object is coming down, then the velocity, the value of v that we will plug in will be with the minus sign. Okay, just like if you're using acceleration, you have to see whether the object is accelerating, so you take it as positive, or if it's decelerating, so you take it as negative. Just like that, when you're using velocity, you look at the direction and then figure out the sign as well. Okay, more about that later. First, we're going to start with some easier ones, and then we're going to do the we're going to get to equations of motion later. I don't think we will have enough time to do that today. First, I would like to do just displacement, velocity, time graphs with you guys. So is it always positive up? No, you can define the direction yourself. Okay, you can define the direction yourself as to what you're taking as positive and what you're taking as negative. Or sometimes the question will help you determine. So if the question says that when an object is thrown up, its velocity is so and so, so that means the question has already considered a certain direction to be positive. Now, if it's traveling in the opposite direction, you take it to be negative. Yeah, right or left also have the same concept. Okay, so now we're going to talk about displacement time graphs. So previously we used to learn how to sketch distance time graphs. Now we're going to learn how to sketch displacement time graphs. Not a major difference. It's just that distance time graph can never go in negative, whereas displacement time graph can actually go in negative as well. So the scenario that we are going to assume is that you go to a cinema. Okay, so you leave your house, you go to a cinema, you watch a movie, and then you come back home. Okay, I repeat. The scenario is you leave your house, you drive to the cinema, you sit there, you watch a movie, and then you come back home. Okay? All right. So this is the starting point. Let's call this O. And this starting point is representing what? This is representing your house. Okay? Because that's what your starting point is. That's where you start your journey from. Okay? Now, when you're driving to the cinema, what does your displacement look like? Here's your displacement in kilometers. Displacement, remember, is usually referred to. We use the letter S for displacement. Okay. So when you're driving to the cinema, can anyone tell me what the graph will look like? Assuming that you're moving at a constant velocity. What will the displacement time graph look like? Positive gradient, that's correct. What kind of a line will we have? Okay, when you say straight line, you gotta narrow it down. You know, this line is also a straight line. This line is also a straight line. Yes, upward sloping. Okay, all lines are straight. So we have an upward sloping line, and we'll continue to have an upward sloping line for as long as we don't reach our destination. Okay, so let's say this is O, and let's say this is A. So let's describe the journey as well. So what's happening from O to A? The distance is increasing. Okay, the distance from the starting point is increasing, but if I leave it at that, that's incomplete. The distance is increasing at a constant rate. And this constant rate, by the way, means that the velocity is constant. Constant velocity. Okay, why is the velocity constant? Because if I take the gradient of this line, I end up doing distance over time. Okay, I end up doing distance over time. Distance from the starting point over time. What's distance over time equal to? That's equal to speed or velocity. Okay, and if I take any 2 points on this line, any 2 points, I will get the same gradient. And getting the same gradient means I'm getting the same velocity, which means the velocity is constant. Okay, so here let's call this T1. Okay, all right. Now, while you're watching the movie, what does the graph look like? So you're sitting in the cinema and you're watching a movie. Yes, now we have a horizontal line. That's correct. Okay, so we're gonna have this horizontal line for as long as we are in the cinema, for as long as we don't start moving. Okay, and what does this line represent? What is AB representing? AB is representing the fact that the distance from the starting point is not changing. Okay, and if the distance is not changing, that means the velocity is equal to 0 meters per second. Okay, yeah, at rest. You're at rest, so that means the velocity is 0. And let's say time here is T2. Then you're done watching the movie and you're going back home. So as you're going back home, what will the graph look like? It's going to be a downward sloping line. Okay, and you will have a downward sloping line for as long as you don't reach the starting point. That means you don't reach the x-axis, and once you reach the x-axis, what is the y value? The y value becomes 0. Why? Because your distance from the starting point has become 0. Okay, let's not take this to be time in seconds. Let's take this to be time in hours. Okay, so what's happened from B to C? From B to C, the distance is decreasing. at a constant rate, which means that the velocity is constant except that it's negative. Okay, the velocity is constant except that it's negative. Why is it negative? Because the object has now turned and it's traveling in the opposite direction. Okay, now let's assume that you didn't go home. Okay, you went to a point which is further away from home but in the opposite direction. Okay, you went to a point which is away from home but in the opposite direction. Like, think of it this way. So here's your house. All right, here it is, house, and this is the cinema. Okay, so you went to watch a movie, you came back, but now you want to go to a mall. Okay, and the mall is further away from the house. In that case, the graph will go beyond the x-axis. Okay, so this is something that's new for us. Previously, in O-level math or IGCSE math, we didn't. I'm talking about math here. I'm not talking about physics. I think you do this in physics, but in math, our graph would never go beyond the x-axis. But here, it's possible that it may go beyond the x-axis. And what's important is to understand what it represents. Okay, this basically shows that the object has gone beyond the starting point. And that's not enough. Also mention in the opposite direction. Okay, so any questions? If yes, please feel free to ask. If not, I'm just going to write down a few key points. Key point number 1, gradient. Yeah, there can be a curved graph as well. Again, something new for you guys. Previously, we used to deal with straight lines. Actually, in math also, there were some rare cases where we had a curved graph, but we didn't have equations that gave us a curved graph. Here, we're going to have equations that can give us a curved graph. Gradient of displacement time graph gives what? Gradient of displacement time graph gives velocity. Okay, and doesn't take a lot of rocket science to understand that. When you find the gradient, you're doing the change in y divided by change in x. Or what do you have on the y-axis? You have displacement, okay, which is a form of distance. What do you have on the x-axis? You have time. So what do you end up with? You end up with distance upon time, except that it's displacement and not distance, which is why you get velocity. Okay. All right. So this was just a refresher. Okay. I mean, most of it was a refresher except for this part. Now, if you have any questions, feel free to ask. We're going to look at a velocity time graph, and then we are going to do an example of. We're gonna then look into a velocity time graph, and then we are going to solve some questions from past papers. Yeah, go ahead.
Sir, when you say that the negative part of the graph shows that the object has gone beyond the starting point, what does it mean exactly?
Okay, I'll explain. So remember the example that I gave? So here you are. This is your house. Okay. Excuse my drawing, please. And let's say this is where you went to watch a movie. Okay. So let's see. No, I'm not an artist. Let's see what your journey looks like. Okay. So this is you going from the house to watch a movie. I just realized I spelled it incorrectly. Okay. Now you're sitting there enjoying popcorn, whatever, watching a movie. Okay. And then now you're on the way back. All right. So here you are, you're back home. Okay. But then you realized that you have to go to a point, let's say you have to go to a mall, which is further away from where you were watching a movie. Okay. which is not exactly on the way to your house. It's further beyond that. Okay, this is, let's say this is the mall. Again, excuse my drawing. So when you're going from your house to the mall, so since you considered this to be the starting point, and now where are you going? You're going in the opposite direction. So while you're traveling in this direction, what happens? What does your displacement look like? Your displacement is negative. Okay, when you were back to the starting point, displacement was 0. But now you're going beyond the starting point in the opposite direction. That means your displacement is 0. Does that make sense?
Yes, sir. Thank you.
Okay, you're
Yes,
welcome.
sir.
All right. Acha, let's do another example where we learn how to make a velocity time graph. And I knew that you guys were going to make fun of my drawing, so I've come prepared. So here's what we're going to do. We're going to take an example of a parachutist jumping out of an aircraft. Okay? So you guys have all seen skydiving. Obviously, I'm pretty sure nobody has done it, but you all have seen it, right? Anybody who has done it? There are places apparently where you can do it in Dubai. It's in my bucket. Well, yeah, it's in my bucket list as well. All right, please share your experience with us when you do it, inshallah. So, what are the steps of a skydiver? The first step, obviously, is jumping out of the aircraft. Okay, and you can consider the step before that is actually getting on the aircraft and the aircraft traveling a certain distance at a certain height, and then they jump out of it. Okay, so what we're going to do on the side is we're going to draw the graph of this skydiver over here. Okay, so before that is okay. So here we're going to take this velocity. Actually, let's take the. Just a minute. Let me write down what we're doing. It's the velocity time graph. Okay. So here is what we're doing. This is the velocity, which is going to be in meters per second, and here is time, which is going to be in seconds. Okay. So the second the parachutist or the diver jumps, what happens to the velocity? At this
So
stage, let's call this stage 1. He is just jumped. So what happens?
increases at a constant rate the upward sloping line.
That's correct. Okay. So although it's not all it's not, assuming he's jumping with a parachute. Okay, Asif. So it's not always going to be in a straight line, but let's assume that the velocity is increasing at a constant rate. Okay, because we have to factor in air resistance and all that. So at this point, let's say we're dealing with an ideal scenario and the velocity is increasing at a constant rate. Okay. All right, then what happens? So he's jumped, the velocity is increasing at a constant rate, it will continue to do so, but then there comes a stage where he pulls his parachute, okay, or he deploys his parachute. Now notice he doesn't do that instantly. Okay, it's not like you jump out of an aircraft and you pull the parachute. Why is that? Have you ever thought about that?
So because at that time the speed of the air is quite too much on the person and he is not reached his terminal velocity, it could be a danger for him to explode his parachute or something.
Yeah, you'll hit the plane. Yeah, that's correct. So basically, he needs to get some downward force. Okay, so this is done at a very high altitude. Okay, where there's a lot of air resistance. So as soon as he jumps, if he pulls the parachute, then the downward force will actually be less than the upward force because the parachute is going to accumulate a lot of air, and that air is going to pull him up. So chances are he may never actually end up coming back down. Okay, so that's why the diver has to wait till terminal velocity is reached. Okay, now we don't have the concept of terminal velocity in M1. I know that's a concept that you guys do in physics, but it's one of those good to know things. So terminal velocity is what? Terminal velocity is the maximum velocity that he can reach. Okay, and at that point, what does the graph look like? When he reaches terminal velocity, what does the graph look like? It's a horizontal line. Okay, and why is it a horizontal line? Because the velocity has stopped increasing. Okay, that's the maximum the velocity can get. All right, so let me make this slightly more positive sloping so we have enough room. So here's O, here's A, here's B. Let's write this down as well. Okay, so from O to A, what's happening? The velocity is increasing at a constant rate. And what is this constant rate, by the way? Velocity is increasing at a constant rate. What is this constant rate? This constant rate, what do we define this as? This constant rate is acceleration. Okay, more about acceleration in a minute, but this constant rate is acceleration. Yes, acceleration due to gravity, which is, let's assume 10. Okay, but that's not what's important over here. Just know that this constant rate, the rate of change of velocity, is called acceleration. More about this in detail in a few minutes. Then what's happening from A to B? The velocity is constant. Now, if the velocity is constant, meaning if there is no change in velocity, then acceleration, which measures the rate of change of velocity, is 0. That's correct. So acceleration is 0 meter per second square. Okay? More about acceleration later. Now, then what happens? Then he pulls his parachute. So I have a picture of that as well. Here it is. So now that he's pulled his parachute, what can we expect the velocity to look like? Ideally, of course. Yes, the velocity should decrease at a constant rate, okay? And that is how the parachutist smoothly and slowly hits the ground. Okay? So the third step, actually let me draw this separately. The third step where he pulls his parachute is when, is when the velocity starts to decrease and he hits the ground. Okay, so pulls the parachute and eventually lands, and the velocity is now 0. Okay, so what's happening from B to C? From B to C, the velocity is decreasing at a constant rate. Okay, so from B to C, the velocity is decreasing at a constant rate. What do we call this? What do we call this? When the velocity is constantly decreasing. There's a special name for it. Negative acceleration, which is deceleration. Deceleration. All right. Now, a couple of key points to keep in mind. Okay, let's first shed some light on acceleration. Let's understand the concept of acceleration, and then we'll talk about some key points. Okay, so what is acceleration? Sir, did you listen about an iPhone 15? Yeah, I heard about that, and I also looked into the physics behind that. So the thing is, even if you were to drop it from, let's say, outer space, there's only a certain velocity that an iPhone can reach. Yeah. So a lot of people were amazed given by the amount of height it was dropped from, but chances are that you can reach the same velocity in probably half the distance.
So does that prove that if a human being falls from a specific height, let's say from an airplane, and we put some kind of cushioning down on the place where he'll land, will he be safe without a parachute?
I mean, you'd have to do a lot of math.
Of course, like, I mean, accepting all those facts and calculating everything, will it be safe for him?
Yeah.
Try and get the safe.
I mean, it's worth a shot. But if, yes, let's say you take care of the landing and the cushioning is landable, then yes, I think it's worth a shot. So, मेरी गाड़ी की तरफ.
Velocity related to your weight, like जितना ज़्यादा आपका weight होगा उतनी ज़्यादा आपकी velocity होगी.
No. At a certain point, because you have to consider both factors. After a certain point, when you reach a terminal velocity, so Yeah, I mean, I get your point. So, for example, if let's say you do this in a vacuum. I don't know if you guys have seen that experiment where they dropped a feather and they dropped a hammer in a vacuum environment. Okay, so they
Yes.
both fall at the same rate. Okay, why? Because gravity, the impact of gravity on both the objects is the same. So gravity does not take into account the shape of the object or the weight of the object. But in a real life scenario, yes, you have to consider that because the higher the mass, the higher the weight. Obviously, the weight is your only downward force, right? So the greater the downward force is going to be. But irrespective, you will reach a terminal velocity. Again, the terminal velocity could vary. Like, for example, maybe it's more for one object and not as much for the other. But after a certain point, the velocity will stop increasing. So, yeah, I hope that answers your question. Will iPhone catch fire if thrown from space as we see asteroids in movie coming on Earth? I don't think so. I don't think so. I mean, I'm not the relevant person to ask that question. I don't have that much knowledge about space and asteroids and all that, but I don't think it will. Yeah, that's true. Lower mass objects will reach terminal velocity sooner.
तो जो टर्मिनल वेलोसिटी होती है लाइक वो एक सर्टेन पॉइंट तक रहती है या फिर बट जब तक आप लाइक ग्राउंड हिट नहीं करते तब तक
You hit the ground with that velocity. So
you
if
hit the
you,
ground with terminal velocity,
yeah,
right?
given that there's no resistance, or even if you take the resistance into account, then once you've reached your terminal velocity, then that velocity stays.
Right, sir.
So if, for example, this parachutist here didn't pull the parachute after hitting terminal velocity, then he would hit the ground with this velocity. And then you know what the graph will look like? This is what the graph will look like. What will be the velocity the second he hits the ground? It's going to be 0 instantly. This is what it's going to be like. So here, the whole idea of a parachute is to slow down the velocity and hit the ground with a less velocity. Okay, but if there was no parachute, this is what the graph is going to look like. So he's going to keep on falling, keep on falling, keep on falling. As soon as he hits the ground, what happens to a velocity? Instantly 0. And what happens to the diver? Well, let's hope he lives to tell that story. And is it humane to try it on a human? I don't think so. I don't think so. Khair, anyway. So let's get back to work. Did I miss any? Sir, फिर diver की speed maximum increase हो जाएगी. नहीं, increase क्यों होगी? इसी speed पे रह के फिर इसी speed से he's gonna hit the ground. The speed is not gonna increase anymore. Okay, B is the point where he pulls the parachute. A is the point where he reaches terminal velocity. So the speed will continue to be the same for a certain period of time, and then he pulls the parachute, and then the speed starts to decrease gradually. That's the whole idea of a parachute, to decrease the speed gradually. Okay, not instantly. So instantly jab hota if he hits the ground without a parachute, as we saw earlier. Okay, now, and even if, let's say, mid-air, his velocity decreases instantly, then what's going to happen? Because of the impact, I mean, that could be because of the impact of there's this concept called inertia. So because of that, it could result in a serious injury. So the whole idea of parachute is to decrease the speed gradually. Okay. All right. So quickly, let's talk about acceleration. What's acceleration? It's the rate of change of velocity. Okay. So a couple of key points that you guys need to know. Key point number 1. The gradient of velocity time graph gives what? The gradient of velocity time graph gives what? Acceleration. Okay, that's key point number 1. Key point number 2, area. Area under velocity time graph gives what? Distance traveled. It actually gives displacement. Okay. But when we say distance, we mean distance from the starting point. Okay, so area under the velocity time graph gives distance traveled. Acha, one more thing. If the object is traveling in a certain direction, and then if it turns, so right at the instant when it turns, what is the velocity going to be? So think about it. You throw a ball up in the air, okay? So it's going up, all right? It's traveling up, up, up. It reaches its maximum displacement, okay? It reaches its maximum displacement, and then it starts to come down. So when it reaches its maximum displacement, what is the velocity going to be? Imagine you throw a ball up in the air, and then it's coming back down. So for a fraction of a second, the velocity is going to be 0. Okay? So remember, this third key point is very important. Whenever the object has to turn, velocity is 0 meters per second before it starts to travel in the opposite direction. Okay, so remember, before the ball starts to come back down, the velocity is going to be 0 for a very fraction of a second. Okay, you can't see it with the human eye, but if you slow it down, let's say using a speed camera, then you'll be able to see that yes, the object is 0 for a fraction of a second. Okay. All right, now let's do some questions related to this concept only. Remember, I have divided kinematics into 3 parts. Okay, what if the ball was thrown at a horizontal axis? No, we're talking about vertical movement. Okay, we're talking about vertical movement only, not on a horizontal axis. All right, there's another key point I just remembered. At maximum velocity, what is 0? This is something that we're going to encounter more often when we're doing calculus applied to kinematics, but at maximum velocity. So the object has reached its maximum velocity, the velocity is not changing, that means the acceleration is equal to 0 meters per second. Okay? So whenever there is no change in velocity, doesn't matter if the object is at rest or because if it's reached its maximum velocity or constant velocity, the acceleration is 0. Okay? Now, take a good look at all the key points that I've written. Let me know if you have any questions. I'm going to take out some questions similar to the concept that we have just covered. Okay? And let's do them. Okay, great. So here's a question. This is, by the way, this worksheet I'll share with you guys just so you guys know. Like I said, it's divided into 3 parts. One is graph, the other is constant acceleration, the third is calculus applied to kinematics. Okay, so first let's do a few questions where we deal with just displacement and velocity time graphs. Yes, I can explain the last part. So the last part says whenever the object, at maximum velocity, acceleration is 0 meters per second. So imagine this. Imagine that you're traveling on a highway and you're traveling at a speed of 150 kilometers per hour. And let's say that's maxed out. Okay, you can't travel any faster than that. So if you're constantly traveling at a speed of 150 kilometers per hour, can you tell me what acceleration is? Can you define acceleration for a minute before I get to my next question? What do we measure by acceleration, Asif? Acceleration measures the rate of change of velocity. So if you're traveling at maximum velocity, there is no change in velocity. And if there is no change in velocity, what do we say about acceleration? Okay. So I'm assuming by that you've understood. All right, great. You're welcome. I mean, there is not rate of change when velocity is max. Yeah, so there are 2 scenarios where there will be no change in velocity. When it's traveling at constant velocity or when it's reached its maximum velocity. In both the cases, since the velocity is not changing, that means acceleration is 0. Okay? So quickly, when is displacement 0? A pop quiz. When is displacement 0? at origin, or when the object is back to the starting point. Correct. When could be velocity 0? When is velocity 0? Yes, when displacement is at max or when the object is at rest. Okay. No, acha, see, that's the tricky part. When acceleration is 0, is it necessary that velocity is also 0? No, that's not necessary. Okay, so don't fall for that trap. Just because acceleration is 0 does not necessarily mean that the object is not moving. The object could be moving at a constant speed, which still results in 0 acceleration. Okay, so just keep your eyes and ears open. Now, like I said, I've taken out questions similar to the concepts that we have covered. Okay, so in these questions, we're not going to encounter differentiation, integration, or anything of that sort, or equations of motions. These are just questions related to the concept that we've covered. Okay, that's how kinematics is divided. So let's do this question. Sorry?
Sir, I have a question.
Go ahead,
Sir,
go ahead.
In M1, the differentiation and integration we have, is it P3 level or P1 level?
No, it's P1 level because you don't have trigonometric differentiation, you don't have exponential logarithmic, it's P1 level. Okay, and yeah, thank you for reminding. When I'm doing calculus applied to kinematics, I will be assuming that you know differentiation and integration, okay, of P1. If you know differentiation of integration of ADMATS, that's even better, but of P1, you must. Can you re-explain acceleration point? Which point? 1, 2, 3. Acha, wait. Yeah, 1, 2. Yeah, 1, 2, 3, or 4. Last part. At maximum velocity. So I just gave an example that if you're moving at a maximum velocity, in fact, let me add constant velocity as well. Okay, so if you're moving at constant velocity, what will be acceleration? So let's see what acceleration actually tells us. Acceleration tells us what is the rate of change of velocity. So if the velocity is the same throughout, could be maximum, could be constant. What does that mean? That means there is no change, which means there is no acceleration, which is why acceleration is 0. Okay, does that make sense? Okay, great. All right, let's do some questions. The diagram shows the velocity time graph for a train which travels from rest at one station to rest at the next station. So this is from rest from one station, and then this is back to rest to the other station. The graph consists of 3 straight line segments. So remember what I said, all lines are straight. So this is a straight line, this is a straight line, this is also a straight line. The distance between 2 stations is 9040. So what do we have? We have the velocity time graph, and what are we given? We're given the distance, okay? Let's see how we can connect the two. Before that, let's answer the first part. Find the acceleration of the train during the first 40 seconds. So what is it? Yes, what is it of this graph that could give me the acceleration? It's the rate of change of velocity or the gradient. So the gradient is going to be 16 minus 0 over 40 minus 0, or simply 16 upon 40, which is going to be 2 upon 5, which is equal to 0.4 meter per second squared. Or usually, no, not 2.5. It's going to be 2 over 5, okay? Or usually the unit that you will see in marking scheme is although meter per second square, but it's written like this, okay? ms minus 2. It's like shifting the power from the denominator to the numerator. That's why it becomes negative. Find the length of time for which the train is traveling at a constant speed. Okay. So before I can find out the length of time for which the train is traveling at a constant speed, I need to find out this time. How can I find out this time? What is the key piece of information that I can use to find out this time? Total distance. Very good. What shape is this? What shape are we looking at over here? Triangle. Okay, yes, we're looking at multiple triangles, but this shape at all at once, this shape as a whole is a trapezium. Okay.
Sorry, I thought you were talking about the other one.
Nani. Yes, it's 2 rectangles and 1 trapezium, I agree, but sorry, two triangles and 1 rectangle. So what we're going to do is we're going to use the area, which will give us the total distance, and equate that to 9040. Now let's call this t. Okay, you can call it x, a, b, c, whatever, that's irrelevant. Now I am assuming that you guys know how to calculate the area of trapezium. Am I wrong? Yes? Okay, that's very nice. So let's at least write down the formula. Half into sum of parallel sides. What do we multiply that with? Height. That's correct. Good job. Okay, and since we're dealing with a velocity time graph, remember the area under this graph will give us the distance. So half into sum of parallel sides. Now the question is, how do we get the parallel sides? So one side is going to be this side, which is 600. Okay, so 600 plus, what about the other side? What about this length? What will this be? 500. How do you know that? How do you know it's 500? Have you worked it out?
Sir, because 0 to 40, 600 minus 40, 560, sorry, sir, would be...
Oh, no. It doesn't say that the rate of deceleration is the same as acceleration. Okay, there's nothing which tells us that this slope and this slope will be the same. Yeah, it's going to be t minus 40. Okay, so this length is t, and from till here it's 40. So this length is actually going to be t minus 40. Okay, so this is going to be t minus 40. I hope everyone understands why that is. This is very similar to O levels. Okay, and what about the height? What's the height going to be?
16, sir.
16. And what is this going to be equal to? This is going to be equal to 9040, because that's the total distance. Okay, now all we have to do now is just simplify. So 2 1s are, 2 8s are. Let's take 9040 divided by 8. That's 1130. So 600 minus 40 is 560 plus t is equals to 9040 divided by 8, which is 1130. So t will be equal to 1130 minus 560, which is 570. So is that it? Is 570 the answer to this question? Is 570 the answer to part 2, or you have to do something else? Nope, it's not the answer. Make sure you're reading the question carefully. The question asked us to find out the length of time for which the train is traveling at a constant speed. So we know it's traveling at a constant speed from 40 to t, which is 570 now. So 570 minus 40, which is equal to 530 seconds. Okay. It's a 2-mark question. You can argue it's a lot of working for 2 marks, but that's how it is. Find the distance traveled by the train while it is decelerating. Okay, what do we have to do now? We have to find out the distance traveled while it's decelerating. So without giving me the final answer, tell me what we're going to do. Area of triangle, which triangle? The first one or the second one? One from 0 to 40 or 570 to 600? The second one. That's correct. Why? Because deceleration means speed must be decreasing. Where do we see the speed decreasing? This is where it's decreasing. Okay. Why did we subtract 40 from 570? Asif, I would like you to read the question and tell me if you find the answer to it. So I'm going to zoom out just enough so that you can read it. So half into 30 into 16. Okay. Half into 30 into 16, which is... Oh, I can use the calculator. Half into 30 into 16, that's 240. Okay, so here's another question which I would like you guys to solve. In fact, wait a minute. Acha, one equation which I forgot to write down. This is going to be one step closer to equations of motion. So when we say the gradient of velocity time graph gives acceleration, so the equation is, this is what the equation is. A is equals to V minus U upon T. Okay. A is equals to V minus U upon T. Now what does that mean? What is V? What is U? Those of you who have done physics would know, but those of you who haven't, let me explain to you guys. V is the final velocity. Okay. U is the initial velocity. and t is time, but not just time, it's actually the change in time. Okay, so I repeat. If you're calculating the acceleration, you take the final velocity. So let's say the question says calculate the acceleration from t equals to 5 to t equals to 7. So you take the velocity at 7, you take the velocity at 5, and then you divide by the change in time, which is 2, since it's from 5 to 7, and that's how you get your acceleration. Okay? Because you might need it in a question, which is why I thought it would be a good idea to do it. Okay, now let's try and solve this question. It says the diagram shows a velocity time graph which models the motion of a tractor. I want to solve at least 2 more questions after this one. Okay, so let's speed up. The graph consists of 4 straight line segments, 1, 2, 3, 4. The tractor passes point O at time equals to 0 with speed u meter per second. The tractor accelerates to a speed of v meter per second over a period of 5 seconds. So keep looking at the graph simultaneously. It's gone from v to u to v in a matter of 5 seconds. And then travels at this speed for a further 25 seconds, which is why it's from 5 to 30. The tractor then accelerates to a speed of 12 meters per second. So have a look at that also over a period of 5 seconds. So again, it does that in 5 seconds. The tractor then decelerates to rest over a period of 15 seconds. Okay. Given that the acceleration of the tractor between t equals to 30 to t equals to 35 is 0.8, find the value of v. Okay. So we're given the acceleration, which is 0.8. What do we know about acceleration? We know it's the final velocity minus the initial velocity upon time. Or in other words, this is just a fancy way of writing the formula for gradient. Okay, it's the gradient of this line. So what's the final velocity? It's 12. What's the initial velocity? It's v. What's the time? It's 5. And what is this equal to? It's equal to 0.8. We can use this equation to find out the velocity. 5 into 0.8, that's 4. 12 minus 4 is equals to v. So what's v equal to? V is equal to 8 meters per second. Yes, that's correct. So before I move on to the next part, take a good look at this. Let me know if you have any questions, because they're all connected. Okay, so I'm judging by the silence, no question. Given also that the total distance covered by the tractor in 50 seconds of motion is 375. Find the value of v. All right, this is where things start to get technical. Okay, so what are we given? We're given the total distance covered by the tractor in 50 seconds is 375. Find the value of u. Okay, so how will we find out the value of u, considering we now know the value of v, which is 8? So can you crop the graph to part 2? Yeah, I can do that. I can do that. Okay, why don't you guys try this? I'll give you 2 minutes. You already know the concept that you have to use, so try it out. There is a considerable amount of working. Okay. It's a 3-mark question. So a 3-mark question in M1 means there is a considerable amount of working. Yes, I can repeat the first part. In the first part, you were given the acceleration from 30 to 35. Okay, and you had to find out this velocity. So what's acceleration? It's the change of velocity over the change in time. So what's the change in velocity? It's 12 minus u. What's the change in time? It's 5 seconds. So that's what we did. Equated it to the acceleration, which was given, cross multiplied, and got the value of v, which turned out to be 8. That's why you see 8 over here. Okay, go ahead. Find the value of u. 6 is the answer. All right, let's check. So I'm going to solve this now. I would have waited, but like I said, I want to solve at least 2 more questions. I don't know if I'll be able to do that, but let's see. So when I said you can be a bit creative, you know what you can do? You don't have to find out the area of all, you will have to find out the area of all these regions, but you don't have to find out all the area, add them up, and then equate it to 375. Here's how you can be a bit creative. You can find out the area of this region. Okay, what is this going to be? This is going to be half into 12 into 15. Okay, half into 12 into 15. What's that equal to? Let's work this out. 0.5 into 12 into 15. That's equal to 90. Okay, then let's find out the area of this trapezium. So I'll do it directly in my calculator. 0.5 into... Acha, wait a minute. I think let's just do it the conventional way. I had an idea, but I realized that this... No, wait a minute. Never mind. This will work. So let's find out the area of this trapezium. It's going to be 0.5 into sum of parallel sides, which is going to be 8 and 12, into the height, which is going to be 5. So that's 50. Then let's find out the area of this rectangle, which is going to be 25 into 8, which is going to be 200. So if the area of this rectangle is 200, this is 50, and this is 90, can we find out the area of just this trapezium? Yes or no? 6 is the correct answer, by the way. Yes, we can. How? Simply subtract all these areas from 375. This will save you from a lot of working. Okay, so subtract 90, subtract 50, subtract 200. So 375 minus 90 minus 50 minus 200 gives us 35. So that means the distance traveled from 0 to 5 is actually equal to 35 meters. Now we can form an equation using the area, half into sum of parallel sides, which means u plus 8, into the height, which is 5, equals to 35. I thought this was the... okay, that's brilliant. 5 ones are 5, 5 sevens are 35. So u plus 8 equals to 14. Cross multiply, u is equals to 6 meters per second. Okay, I was afraid that maybe you guys will find out the areas of all these shapes, then add them up, and then equate to 375. This way, it's just a lot less working. You still have to find the area. Okay, there's no getting away from that, but it saves you a lot of working. Okay, so any questions? If yes, please feel free to ask. If not, then let's move on. Okay, perfect.
What exactly did you do here? I didn't get it.
So here's what I did. I broke down the figure into multiple shapes. Okay. Theoretically, the area of all these shapes is equal to 375. That means the area of this trapezium plus this rectangle plus this trapezium plus this 90 is equals to 375. So what I did was I found the areas of the shapes that I could, subtracted them from 375. I was left with 35. So 35 is just the area of this region. So I found the area using the equation of trapezium, using the area of trapezium formula, and equated it to 35. That's what I did.
But you still found out the areas of all the shapes.
Yeah, like I said, you still have to do that. ठीक है, but इससे आपकी working थोड़ी neat हो जाती है. Okay. All right, let's do another question. This is a question where we have to make the graph. Okay, that's why I want to do this question, and it's a fairly recent one as well. It's May, June 2020. Not very recent, but very relevant. Okay, so it says here, a tram starts from rest and moves with uniform acceleration for 20 seconds. Okay. Now, whenever you're dealing with a sketch question, please make sure that you first read the entire question before you start sketching it. Okay. A tram starts from rest and moves with uniform acceleration for 20 seconds. Okay. The tram then travels at a constant speed v meters per second for 170 seconds before being brought to rest with a uniform deceleration, magnitude twice that of acceleration. The total distance traveled by the tram is 2.775 kilometers. Okay. So when we're making this graph, the velocity should be in meters per second. Okay, and the time should be in seconds. Okay, now let's look at the first part. When it starts from rest and moves with a uniform acceleration of 20 seconds, what will that look like on this graph? What will that look like? What kind of a line? Upward sloping line? That's correct. It's going to be something like this. Okay. Then it travels. Acha, let's label this as well. So it achieves this velocity in a matter of 20 seconds. Okay, and this velocity is v. And then it travels at this velocity for how long? For 170 seconds. So what is this going to be? Is this going to be 190 or 170? It's going to be 190. Okay, because it travels at this velocity for 170 seconds. So here comes the tricky part. Then it's brought to rest with a uniform deceleration, magnitude twice that of acceleration. So can you tell me what will, yes, very good, Momina. What will the downward sloping line look like? It will be twice as steep as this one, except it's going to be a negative sloping line. Okay, so it's going to be something like this. You can see it's a lot steeper. Obviously, you're making a sketch over here. Okay, you're making a sketch over here, so you can't measure the gradient and then make sure it's twice of that. But you have to make sure that this line is steeper than this line. Okay, significantly steeper. Yeah.
We we don't want it to be accurate. We just want to show that it is actually steeper than the before.
Yeah.
Okay.
Because what are we doing? We're making a sketch. Keep that in mind. We're not plotting. We'll never be asked to plot. Okay. Sketch a velocity time graph, and what are you given? You're given that the total distance is 2.775. Okay, now if you think about it, you have quite a few unknowns because you're not told the time that it takes to come to rest. Now, you're not told that, but can you figure it out? Can you figure it out? 10 seconds. Very nice, Ryan. How? Yes, because the time will now be halved. Because the gradient is twice as steep, how long did it take to go from 0 to v? It took it 20 seconds. But because it is now decelerating at twice the magnitude, that means how long will it take to go from v to 0? It's going to take half the time. Okay, inversely proportional. That means the journey ends at 200 seconds. Okay, this is going to be 10 seconds, which means the journey ends at 200 seconds. And now if you think about it, this is a very easy question. Okay, why? Because you need to find out v. What are we going to use to find out v? Yes, twice means the magnitude, the time halves. Gradient? Really? Are we going to use the gradient to find v, or are we going to use area? Exactly. Trapezium formula. So half into sum of parallel sides. One is 200, the other is 170. Into v, what are we going to equate it to? We're not going to equate it to 2.775. Keep your eyes and ears open. We're going to equate it to 2,775. Why is that? Can anyone quickly explain? Why am I equating it to this and not...
Because the graph is in meters.
Yes, so whenever you have the graph in meters per second and the speed in meters per second and time in seconds, you get the distance in meters as well. Okay? So since we're given the distance in kilometers, we have to convert it to meters. And then, of course, you can cross multiply and solve and end up with whatever. Let's solve it, in fact. Let's see what do we get. It's going to require a lot of calculation. 2775 into 2 divided by the sum of 200 plus 170. So v is equals to 15 meters per second. Okay. Then it says find the magnitude of the acceleration. So
what did you do to find v?
I use the area because we're given the total distance. The total distance is 2.775. What is it of this graph that will give me the total distance? The area. Okay. So the magnitude of the acceleration, now that you have velocity, you can find out the magnitude 15 minus 0 over 20, which is 3 upon 4, or 0.75 meter per second square. That's it. Okay, so let's stop here. See you guys soon, inshallah. Next P1 mock, I'll announce in the group. Fawaz, I'll announce in the group. Okay. So that's it, fellas. Take care. Allah Hafiz.